Okay, let's dive right into this explainer. Today, we're unpacking a really fascinating piece of science and curriculum from the heroesmartacademy Godly Learners series. It's titled The Coriolis Effect, Godly Design in Global Motion. What we're going to do is break down the literal mechanics of our spinning planet, and then, this is the really interesting part, explore how this source material connects complex atmospheric physics to a much larger philosophical framework of balance, design, and morality. It's basically a great example of using the how of our physical world to ask the bigger why questions. So let's get into it.
We're kicking things off with a massive weather mystery. You've probably seen this on the news, but maybe you haven't fully dug into the why just yet. If you pull up satellite footage of a hurricane hitting Florida and then compare it to a cyclone hitting Australia, well, you'll notice something pretty peculiar. They're spinning in completely opposite directions, right? Florida storms spin counterclockwise while Australia's spin clockwise. And it's not random at all. It's highly predictable, and it's governed by this invisible, omnipresent force that's acting on you, me, and the air around us right at this very second.
Here's what we're going to cover today. We've got 5 sections. 1. The invisible steering wheel. 2. Science of the spin. 3. Storms, flights, and currents. 4. Debunking the toilet myth. And finally, Section 5. Education, morality, and design.
All right, moving right along to Section 1, the invisible steering wheel.
You know, it's incredibly easy to forget that we're literally standing on a spinning rock hurtling through space. But the atmosphere? It never forgets. The air around us is constantly reacting to this rotation, acting like a giant, invisible steering wheel that guides the weather. And the source material actually anchors its lesson right here with this quote from Job, reminding us that humanity has been marveling at these driving winds for millennia. Think about it. Long before we had weather satellites or complex physics equations, people were looking up at storms and recognizing a massive orchestrated system at work. Today, we get to look at the exact mechanics of how that system operates.
Which brings us perfectly to Section 2, Science of the Spin.
Because Earth isn't just sitting still, everything traveling across it, whether that's a gust of wind or a massive jet airliner, has to contend with its rotation. So here's the crucial definition, the foundational big idea of today's lesson. The Coriolis effect is the phenomenon where winds and currents curve rather than traveling in a straight line, all because the Earth is spinning. Think of it like this. Imagine trying to draw a perfectly straight line with a marker from the center of a spinning record out to the edge. Even if your hand moves perfectly straight, the paper is moving beneath you, so the line you draw actually ends up curved. That is exactly what's happening to the air and water on our planet.
And because the Earth is a sphere, the speed of its spin isn't the same everywhere. This is the exact mechanism that causes that apparent curve. To put this into perspective, the Earth takes 24 hours to complete one full rotation, right? But the distance around the equator is vastly larger than the distance around the poles. So to make one full rotation in that same 24-hour window, the land at the equator has to move much, much faster. We're talking roughly 1,000 miles per hour. Meanwhile, if you're standing right at the North Pole, you're barely moving at all. You're just slowly turning in a circle. This massive difference in speed is what creates a drastic deflection in the atmosphere.
Now, notice the stark contrast here between the top and bottom halves of our globe. As air moves north or south away from the equator, it holds on to that high rotational momentum. In the northern hemisphere, the physics translates to a deflection to the right. So when low-pressure systems pull air inward, that rightward deflection forces the storm into a counterclockwise spiral. In the southern hemisphere, the deflection is to the left, which creates a clockwise spiral. It's honestly just a beautiful mathematical mirror image.
Let's jump right into Section 3. Storms, flights, and currents.
See, the Coriolis effect isn't just some abstract theory you memorize for a physics test and then forget. It's the literal engine of our global climate, and it's absolutely critical for global transportation. Without this effect, there's no way we'd have those spiral-shaped hurricanes or precise ocean currents or even the complex flight paths that airplanes use every single day. The trade winds, the ones historic explorers actually used to sail across the globe, they curve westward entirely because of the Coriolis effect. It takes the chaotic heat of the sun and the vastness of the oceans and organizes them into structured, predictable currents of air and water that sustain ecosystems all around the planet.
This right here brilliantly illustrates how the Coriolis effect helps regulate entire climate zones across the Atlantic. The Gulf Stream acts as this massive oceanic conveyor belt. It gathers up warm water from the Gulf of Mexico, and then, guided by the Earth's rotation, it pushes that warm water all the way up the eastern coast of the US and across to Europe. This is exactly why countries like the UK have a significantly milder climate than other places sitting at the exact same latitude. That unseen curvature of the ocean's path is quite literally warming entire continents.
And it's not just the weather. Even pilots have to do mathematical gymnastics to adjust for this invisible steering wheel. When a plane takes off from New York heading to London, it doesn't just point the nose in a straight geometric line and hit the gas. Nope. While the plane is up in the air, the Earth is continuously rotating beneath it. So pilots and automated flight systems have to constantly calculate and adjust their trajectory to account for the Coriolis effect. They are essentially flying a calculated curve just to end up perfectly at their destination.
Moving right along to Section 4, Debunking the Toilet Myth. Okay, we've talked about huge systems like oceans and airplanes, but what about the water in your house? It's time to bring the science down to the smallest room in your home and bust a very popular, slightly gross myth that I know you've heard before. It sounds like a fun science fact, but it's entirely false. The myth goes that if you flush a toilet in New York, the water swirls one way, and if you flush it in Sydney, Australia, it swirls the other way, all because of the Coriolis effect. You see it in movies, TV shows, pub trivia. But as our source material clearly points out, this one is completely busted.
The key to debunking this is simply a comparison of scales. The Coriolis effect is an epic global force. That means it is way, way too weak to have any say whatsoever over the tiny amount of water in a toilet bowl. It needs hundreds of miles and hours of time to actually make a noticeable impact, like it does with global winds. The water in a toilet basin is influenced almost entirely by the physical shape of the bowl and the angle of the water jets. The Earth's rotation is just totally overpowered by the localized mechanics of your plumbing. Sorry to ruin that fun fact for you.
Finally, let's wrap up with Section 5, Education, Morality, and Design. Here is where the source curriculum really bridges the gap between atmospheric physics and personal philosophy. The Godly Learners series uses the Coriolis effect as a metaphor, arguing that it reflects a highly intricate level of planning in the universe. They posit that just as this unseen hand steers massive global weather patterns through very subtle rotational speeds, a similar subtle guidance orchestrates balance in our own daily lives.
The heroesmartacademy philosophy actually poses a pretty profound central question here. What is the point of being highly educated if we just go on making choices that hurt ourselves and others? They make the argument that teaching science, like the mechanics of the Coriolis effect, without also teaching a moral framework, leaves education fundamentally incomplete. Education without morality, they suggest, gives people intelligence and power, but without the wisdom to use it properly. So by intertwining scientific education with biblical truth, the curriculum's stated goal is to equip learners to make positive choices that genuinely benefit themselves and the world around them.
According to the source text, intertwining education with this kind of biblical morality promises something specific, a profound peace of mind. Highlighting a passage from Romans, the curriculum suggests that engaging with education through a spiritual and moral lens isn't just about memorizing facts, it's about achieving a state of inner peace. The idea is that understanding the vast, complex, and beautifully ordered mechanics of the globe, like the precise curvature of the winds, can actually inspire a real sense of spiritual awe and tranquility for the learner.
As we wrap up this explainer on the Coriolis effect and the curriculum's unique perspective, I want you to ask yourself this final homework question to keep your mind turning. Think about it. What would Earth's weather actually be like without the Coriolis effect? If the Earth just stood completely still, heat from the equator would travel in a straight, boring, uncurved line right to the poles. We wouldn't have those swirling storms, or the ocean currents distributing warmth, or the incredibly complex weather patterns that make our planet so diverse and habitable. It's a fantastic thought experiment to realize just how crucial this invisible steering wheel truly is. Thanks for joining me for this explainer. Keep your curiosity spinning, and I'll catch you next time.